All right. I think we're set. How about a question show en français, s'il vous plaît? Let's taste the Canadian school system. That would fail. My français ne pas très bien. Je parle anglais. We in the on the West Coast, I mean, we learned French, and so we learned a little bit in elementary school, and then we mostly had to learn French in high school, like grade 8 through grade 10. So we really don't get a lot of French experience in Western Canada. Which is too bad. And I knew this was a problem, so I put both of my kids into French immersion. And so they both speak French really well. My eldest is completely fluent, did from grade 1 through grade 12. And so is utterly fluent in French. My younger was sick of French immersion and so switched to kind of regular English schooling in grade 8, grade 9. So yeah, his French is a little weaker, but he could easily pick it back up if he wanted to. Both of their French is better than mine. It's too bad. I think it's funny because as I'm famously trying to learn Chinese, and the French still comes back. Like I learned it 40 years ago, and yet the French still is retained because I learned it as a child. While the Chinese is sort of these fresh memories that I'm building. And I learned Spanish. I did a year of Spanish at university maybe 15 years ago, and it's gone, completely gone. And yet I remember I was talking with somebody in Spanish, like a friend in Argentina, I think, and we were talking on Zoom or whatever was the equivalent back then. And he was like, "Oh, your Spanish is actually pretty good." And I was like, "Oh, we learn a lot of French. I'm sure there's a lot of overlap in sort of accent and being able to roll our R's and things like that." And now it's just, gone. So I could probably take another year and switch, right? Drop Chinese, switch to Spanish, get that back up to speed. I could probably do a year on French, and then I probably could do a podcast in French, which would be interesting. It's always so tempting. I really love languages. I love learning different languages. And it's always so tempting that, a lot of these languages are sort of right there underneath the surface that I could go and drag them back out. And there would be a lot less misery than learning Chinese. But yeah, when I'm watching a movie and someone is speaking in Chinese and I understand what they're saying, and I'm like, my wife is like, yeah, I know. You've understood what they said, right? And I'm like, yeah, his accent's really good. It's pretty funny. Okay. So you're wondering what it is that you have stumbled into. This is going to be the live question show. Your questions, my answers. You know the drill. Go ahead and put any questions that you have into the YouTube comments. Now, I've theoretically got my... we don't have a moderator here yet, but in theory, the question should be going into the database, but I don't see any has gone in yet, but we'll see if it's just a matter of them not being posed as questions. So we'll give it a second. But if not, we have backups on our backups. So the way this works is that I will look through all of the questions that everybody asks me. And if, go ahead, just put your question into the YouTube comments. Just put it in once. Don't put it in multiple times. A few ground rules. I try to give emphasis to the people who've never had a question answered before. So if that's you, I like your chances. I am a journalist, not a scientist, so I cannot provide you any additional information, and I will sort of drop into a rant about why it's important for us to trust experts at the drop of a hat. Let's see, did that? Yeah, so I like your, so just keep that in mind. Not a scientist. I'm a journalist. And then I try to sort of avoid the questions that we get a lot of. So, it looks like the database is not being filled in, which is too bad. So I can do this the old school way, the way regular YouTubers do this, which is that they read through the YouTube chat. So we're going to have to go that way. And I apologize in advance to Chad that he's going to have to now search for the names and the questions in the YouTube comments, but we're going to have to do that. So, okay, let me see if I can find a question. It's hot in here. Let me turn that on. Okay. Casey Ream. What would rovers for moons or dwarf planets with icy surfaces look like? Would they move more like snowmobiles? Yeah, that's really interesting. We're very familiar with just the straight up the rover, the four-wheeled, maybe the six-wheel rover that is, designed to roll around on regolith, maybe, find the occasional rock and drive around it. But the engineers at NASA and ESA and the Chinese Space Agency have been working on different kinds of vehicles for different kinds of surfaces. And, I've covered them in bits and pieces, and I keep meaning to do an episode about all of the really amazing extreme ideas for rovers that have been proposed. And I'm just going to sort of run you through a bunch that I really like, because it's beyond just like navigating on a snowy surface, because I think like with a snowmobile, if you've ever ridden on a snowmobile, like part of it is the velocity that you are moving very quickly and you're trying to skim above the surface. But it's probably not that we're going to find snow, like freshly fallen snow, powder, right, on the surface of Enceladus or Europa or something like that. These are places that have been covered by ice. The ice has been exposed to space, the vacuum of space, for millions, some cases billions of years. It's getting pounded up by micrometeorites. And so in some cases, it is being turned into something that would be analogous to snow, but not sort of light and powdery, but more like crushed up corn snow. We have many different names for snow here in Canada, but just like little balls. So think regolith, but now it's snow or ice, right? Little just pulverized ice into this sort of really kind of powdery ice. But then there are these features, and I apologize, I forget the name of them, but there are these essentially ice spikes that appear. And sort of the conditions, we have the conditions here on Earth. You find them on glaciers, on mountains, and they sort of build over time. And it looks like a whole bunch of spikes. And that those same features are thought to be on the surface of places like Europa and Enceladus. So it's not going to be this fresh powder. And so, you're thinking of an idea like, would it be a snowmobile? Maybe, but probably not. You would want some kind of rover or vehicle that could drive across those kinds of landscapes. If you're lucky, your wheeled rover will work, but you're probably going to want bigger wheels. If you're not lucky, then other kinds of locomotion start to make more sense, like some kind of hopper, right? There was an interview that I did with a researcher who was working on a hopper for Enceladus, and that this is a one-legged hopper that's able to maintain its orientation, and it's able to jump around on the surface of, right now it jumps on the surface of the Earth, but in theory it could jump around on the surface of Enceladus, and maybe even jump around or even through the various plumes that are coming out of the surface of Enceladus. So maybe you just always are staying on the move. And these hopper spacecraft have been proposed, and I think the Chinese are actually planning to do a test of one of these hoppers, not a one-legged jumper, but a vehicle that's designed to essentially leap off the surface of the moon, perhaps assisted by a rocket briefly, coast for a while on a ballistic trajectory, and then drop down onto the surface at a new location, and then examine its surroundings there. And then you don't really have to be concerned about the intervening terrain. You just leap off the surface, float through the vacuum of space, land softly somewhere else, and now you've got new stuff around you. And then, maybe you can control, know exactly where it is that you're trying to go. Like you've got some kind of map of space or you got a map of the area where all of the interesting geological features are, and then you just leap off the surface of the moon, drift briefly down, and land right beside that rock that you really want to explore. But there's been some other really interesting ideas. So there are snake bots, which not only would allow you to sort of make it across fairly varied terrain, right? If there are those spikes, if there are large rocks, if there are ice crevices, you can make your way across these kinds of things. But also you can go down into caves, small caves, things like that. And there are lots of really interesting snake bot designs. There's a rover that NASA is working on that is designed to crawl along the underside of ice. And so you imagine like there's the ice sheets down at the bottom of the Earth, like at Antarctica, and that this rover is a rover, but it's upside down. So it's buoyant, and its wheels are directed up, and now it's just driving around on the bottom of the ice looking for life. And you can imagine a similar thing, perhaps you drill down under the ice sheet on Mars, and then you deploy this rover. Drill down through the ice on Europa or Enceladus, and you deploy this rover. So there's a lot, and like I'm just scratching the surface. Just so many great ideas for rovers to deal with difficult terrain. There are rappelling bots. So, perhaps you want to explore a cliffside. Then one rover anchors itself to the top of the cliff, and then extends a line down, and then this other rover is able to crawl down the side of a cliff. And you could also use that, for example, going down into a lava tube. So rovers are great if the terrain is really safe. But the problem is that the most interesting places to explore often have unsafe terrain, and that we're going to need entirely new paradigms for vehicles that can actually explore those kinds of places. But yeah, it's all very exciting. I wonder why this isn't catching it. Is it because I paused it? Okay, let me try that. See if that works. And if that doesn't do it, then we will just keep going. John Vincent's Attic. What are the chances Vera Rubin discovers a new target for New Horizons to visit? The chances are pretty good. And in fact, so New Horizons, of course, this is the spacecraft that did the flyby of Pluto. It did the flyby of Arrokoth, and it still has propellant in its tanks. And so theoretically, if there is another Kuiper Belt object that is discovered in its future accessibility cone, then it could be tasked to make a maneuver and try to do a flyby, possibly even two. Like, it just depends. And up until this point, there just haven't been surveys done of the Kuiper Belt to the level of detail that would allow them to find future targets. Are you going to spend the time doing a detailed survey with James Webb when it is already 5 times oversubscribed, and at best you can get 30 minutes to use James Webb before somebody else needs to use the telescope? Like, they're not going to be able to commit the kind of time to do a survey at that depth to find those objects. So we need a survey telescope, and the one that is going to be operational any day now is Vera Rubin. And it is ideally suited for this kind of thing. It is going to find millions of asteroids. It is going to find tens of thousands of Kuiper Belt objects. And because it will be spending more time examining the planet ecliptic, the place where most of the Kuiper Belt objects, everything, asteroids, the Kuiper Belt object, where most of the stuff in the solar system is located, it could very well turn up those objects. It is hopefully going to be the telescope that finds Planet 9. So if it is able to, it will. And if it's not able to, then unfortunately they will no longer have any more targets. Now, we had a bit of a scare, which was that the White House was looking to shut down the budgets for dozens of missions, and it looks like Congress has overturned that decision. And so a lot of those missions are going to be continue to be funded, and one of those is New Horizons. And it's not like it's a lot of money, right? Like you're literally just communicating with the spacecraft, drawing in any of the science that it's still doing in the outer solar system. You know, it's on the order of a couple of $1 million a year to maintain communication with the spacecraft. But we went through the scare where it almost got shut down, and actually earlier as well, not just this current budget crisis, but there was like another point where it had gotten targeted, and this point now it should be safe. And there was a paper that came out, feeling like 6 months ago ish, and we reported on it on Universe Today that the New Horizons team had proposed time in not only on Vera Rubin, but on other telescopes to do follow-on observations to try and identify those targets while they still have time. So this is the plan. Is, you know, there's a lot of scientists that are just waiting on Vera Rubin to deliver those initial surveys to find some of the objects, the supernovae, the asteroids, the near-Earth objects, the interstellar objects, all of that. And one of those will definitely be the New Horizons team that's waiting for a better discovery of Kuiper-Belt objects. So stay tuned for that one. SM Collins. There have been bright flashes. What are the chances of picking up light echoes in the solar system? So, I mean, I think light echoes are a super fascinating idea. And I want to sort of separate that from what you describe as bright flashes. So a light echo is where light is moving through some kind of media, right? So I'll give you an example, right? You get a supernova, and the supernova goes off, and you get this wave of debris that is expanding out from the supernova, but you also have the light, the bright flash that is coming from the supernova. And as this flash is moving through, is sort of expanding, it is going through older material that was in the area. And then as it moves that older area, it reflects off of that older material, and we see this from our perspective. You know, supernova are kind of difficult because by the time we see the supernova, it's sort of that initial flash has already gone past us. But let's think of a nova. You know, a nova is when a white dwarf star gathers up some material on the surface of its, a nova happens when a white dwarf star gathers material from a binary companion. That material builds up on its surface. It flashes off as a thermonuclear explosion, and you get this brightening of the star, and then it goes back down to normal, and then things continue. And so when that nova happens, we see the flash. But if you know that this flash is happening on a regular basis, you can look for rings around the star where the flashes have happened in the background. Essentially, 100 years ago, the star flashed, the light propagated outward from the star, it then hits material that had been shed by the star and reflects off of that material. And so you could actually see concentric rings, old echoes of the light that were caused by the flash, in addition to the one that we're just seeing now. And so it allows you to do this kind of archaeology on stars. And we see different versions of this. We can see when a supermassive black hole was active in the past, because it, you know, maybe it's quiet today, but you'll see the echoes of the time when it was bright in the past. And so, you know, you're talking about there being bright flashes. You know, there are supernova. There are, kilonova, there are nova, and there are lots of different, these kinds of events. But then you have to sort of wait for this light to propagate through the surrounding material and observe it. And there have been some examples, like, you know, the homunculus nebula, sort of the V838 Mon is sort of the classic example of that. You can watch this time-lapse video of V838 Mon and see how the light has propagated through this object and totally changed, and in a reasonable amount of time. You know, the Hubble Space Telescope has been in orbit for 30 years, and so we have these long observations of several objects, and so we are starting to see the light echoes of things that have happened in our lifetime. And so hopefully, you know, the longer we live, the more powerful telescopes we see, we can look back at, say, supernova 1987A and watch further events happening, or other various novas, or watching supermassive black holes turn off and on. Sorry, just looking. Man, it's so much harder when I have to sort of see the conversations. Walleye Cottage Fishing Channel. If you could replace our moon with any other moon in the solar system, which one would you choose and why? Oh, that is rough, because there are moons that I like better than the moon. But the problem is that is because they're in the location that they are. So you think about, say, Titan or Enceladus or Europa or Ganymede or Callisto or all of these moons. If you moved them to be the Earth's moon, then they would grow a tail, and the radiation from the sun would wear away all of the ice and water that surrounds them, all of the nitrogen and the methane and all that kind of stuff. It would just wear all that away, and you would be left with the rocky core underneath. And so you would turn Titan into the moon. You would turn Europa into the moon. Like, you would just end up with this ball of silica and metal. And so I can't think of a moon that, if we switch places and put it to be in orbit around the Earth, that it would still look really cool. All of the cool, Charon, Triton, they have to be kept in their current environment to be as interesting as they are. So now, if I just wanted to briefly throw one of these moons in orbit, then I'd probably choose Iapetus. I think is sort of the one that I'm most fascinated with. It's that yin yang moon where half of it is covered in snow and the other half is like charcoal, and it has this weird ridge on it that is 20 kilometers high. It's a very bizarre, mysterious moon, and one of the places in the solar system that I'm most fascinated by. So but then we need to put it back very quickly. Otherwise, it would lose its charm, and it would just become this, the moon again. Earlier. Casey for golf. What is your understanding about subspace? I have never heard any scientific definition of subspace. I think it's a science fiction term. Kan Tepe. What do you think of the Eric and Wendy Schmidt observatory system? So there was an announcement in the last couple of weeks that the Schmidt Foundation is going to be creating 4 new observatories. And one of them is going to be a space observatory, the Lazuli Space Telescope. It's going to be a 3-meter telescope. It's going to orbit on this orbit that kind of takes it in between the Earth and the moon. So it'll be able to be away from low Earth orbit and won't be clogged up by these mega constellations of satellites. They're going to probably spend 400 million-ish on it, and as well as these other 3 ground-based observatories. And I mean, they all sound great, right? Yes, a 3-meter telescope that is privately funded. That sounds wonderful, and they're hoping to have it launched within 3 years. Sounds great as well. But I think about the promises of billionaires about these kinds of things, and I don't necessarily feel like billionaires can be held to account or can be trusted to deliver on the sort of big science plans that they say they want to. We've seen many missions have cost overruns, and something that you think is going to cost you $500 million, which is like a lot of money, even to a billionaire, obviously, they make more than that in their investments every year, and they could just pay for that just through their dividends. But still, it's a lot of money. And if the cost overruns, how far are they willing to let it keep going? Are you going to spend $1 billion? Are you going to spend $2 billion? Right? If you're going to build this thing with risky technology, you are looking at significant potential cost overruns. And like one school of thought says, no. All the cost overruns happen because it's the old school NASA with a contractor, and these contractors are trying to scam the system and trying to make cost overruns happen, and they don't really care about. Like, I don't think that's true. Like, I think that the way the system is implemented, that the contractors are large companies that are trying to make money. They're trying to fulfill to their shareholders. They don't want to lose money. They have a lot of internal practices that try to keep costs in line. And so whoever you choose as a contractor to actually build this thing, you run the same risk that NASA runs when they choose an outside contractor to build a thing. The difference is that NASA has literally bottomless pockets, right? As long as Congress is willing to continue directing NASA to fund the various missions, the various hardware, they are able to continue doing it. While other companies, realize we're spending good money after bad, sunk cost fallacy, and they just abandon the project. So I think it's and we saw what happened with the Breakthrough Starshot Foundation. They were saying that they were going to give $100 million to researchers looking to develop technology for interstellar flight, and then they ended up spending a fraction of that. Now, Breakthrough Listen is still going, so that's great, because I think it's it's super important as well. I'm researching a video that I'm working on right now, and SETI, sort of the whole idea of searching for extraterrestrial intelligence, was shut down through Congress, through the Senate, through NASA. Like that, essentially, NASA was no longer allowed to search to have any program that was going to be searching for signals from alien civilizations, which is ridiculous because it's a scientific question. And so the whole sort of field of SETI was just wiped out. And it took researchers with connections to actually find people who are willing to help pay for this. And in the end, they were able to find, I think there was like four, like Paul Allen, and I forget the other, there was like 4 billionaires who each contributed about $1 million, $1 million. And they built a bunch of stuff to keep SETI going. And all of this success of SETI that I guess not success, but at least the continued operations of the idea of SETI over decades was really funded for a few $1 million. And so when someone goes, I'm going to spend $1 billion, I am skeptical. I am cynical about this, that I'm like, you probably won't, right? Like you say this and people are going to get excited and you get a bunch of press, but when it actually is required for you to put in the money month after month, when the cost overruns come in and you have to decide about the various things your foundation is paying for, do you have the stomach for this? Because space is notoriously expensive. And, I get this question a lot from people where they say, look, why don't we crowdfund space missions? Like, why do we need to wait for the government? Because it's just so expensive. Like, you just don't understand how much money these things take. So my preference, if I was to advise the Schmidt Foundation, would be that there are a ton of really exciting ideas that are low-hanging fruit. either additions, they could be CubeSat missions, they can be fairly modest telescopes set up here that can test proof of concept. That is that step that then the space agencies and the science agencies would be willing to move on to the next level with this idea. And that you could spend on the order of $1 million here and $1 million there, and you would change the life. You would change the trajectory of an entire field of research. And that would be better spent. I see NIAC, the NASA Innovative Advanced Concepts, as the right direction for this. Don't spend $20,000 letting a researcher take their idea one step further. Spend $100,000 letting that researcher build a prototype. Spend $1 million letting that researcher build a telescope that's actually able to do some science and provide the data for astronomers. So although I am excited at the potential of a new telescope, new ground-based telescopes, this all sounds great. And there are many telescopes that have been funded by millionaires. You look at the Simone telescope on the Vera Rubin Observatory. You look at, there's been a ton, right? The Sloan Digital Sky Survey. It's like right there in the name, and that's provided by the Sloan Foundation. So, but to just like specifically direct, I'm going to build these telescopes, my instinct is no, you won't. That you will fail. And I'm sorry, because I'm excited about the idea and I want you to do this, but I would rather you build the infrastructure that builds telescopes, tests new ideas, pushes technology forward, helps researchers with good ideas be able to move forward. That's so, yeah, man, that's like, I sound like such a downer. But I just feel like I've reported on so many of this that has gone out of business, that haven't happened, hasn't come together. And the things that do seem to succeed are the lower level constant effort. Hey, Zephan showed up. Some too else. As we speak, NATO seems to be blown up over Greenland. Do you see any consequences for missions or results? Like, of course. Like the biggest issue is that the world is routing around the United States. So the United States is, and this is happening before what happened with Greenland, before what happened with Venezuela, right? Like just that, the United States has put all kinds of tariffs on Canada. And for Canada, up until this point, 75% of trade from Canada goes to the United States. We made this bet as Canadians to say, okay, the United States is going to be this country that we are going to have this deep, long, natural partnership. We are aligned in every single way. We have almost the same culture. We speak the same language. We have this giant undefended border. We have the raw resources. The United States has the manufacturing capability. It's an absolute natural partnership. And then, and when the United States needed us to be there during 9/11, when the planes crashed into the towers, all those flights needed to be rerouted. They came to Canada. Shortly after 9/11, when a response was required to go into Afghanistan, Canada sent its troops. That we've always considered the United States to be our best friend. And now, right, we don't think that anymore. Like, just like you talk to any Canadian now about how they feel about the sort of the relationship with the United States, and it is tense. And it's going to take a while to repair. And so how that expresses itself sort of at a larger kind of directional level is Canada's now routing around the United States. So while our trade with the United States is dropping lower and lower, I mean, we're still locked in to a certain point. Our trade with Europe, our trade with the UK, our trade with Australia, all these have gone way up. And in fact, we just completed a trade agreement with China. So we had been putting 100% tariffs on Chinese electric vehicles to help support the U.S. domestic vehicle market. And then, right, all of and had invested in a bunch of factories in Canada. And then that, because of all the tariffs, and now that doesn't make any sense. So now we've dropped the tariffs on Chinese vehicles. So in Canada, we're now going to be able to get Chinese vehicles, which is great. I'm really looking forward to driving. I tried a lot of the Chinese electric cars when I was in Thailand, and they're really cool. The BYD Seal and a bunch of these. So hopefully we can get affordable Chinese built electric vehicles. So that sort of that routing around, you've got the kind of the direct result where the United States has literally said we are no longer going to participate in these various global, the U.S. has said we are no longer going to participate in these cooperative research agreements. The sort of Now, it's kind of complicated because Congress has restored the funding to various projects, but the United States is contributing to the upcoming LISA instrument, the Large Interferometer Space Antenna. The U.S. is contributing to an upcoming European Mars rover mission, probably going to provide the launch services for it, as well as, because the Russians were originally going to be doing stuff, and that relationship fell through. And so now Europe switched to working with the U.S. Well, now that's under concern. So what you're getting is either directly the United States is pulling out of various arrangements to build long-term collaborative scientific missions and such, or you're getting everybody hedging. So instead of choosing the U.S., which is like the world leader, the world expert in various fields, instead of choosing them, you choose a different partner, right? Because a partner who you feel is going to be there when, it isn't going to change their mind or inflict some kind of punishment on you. And so the whole world is routing away from the United States now. You're an international audience. Like if you're American, you're probably not aware of it. But for those of you who live in other countries, you know exactly what I'm talking about. And so what's happening in our lives is happening across all of these giant collaborations. So, in the short term, it's not going to feel like much unless the US actually does pull out of some of these arrangements. The long term is we won't have those kinds of collaborations in the same way without it being very transactional, which is too bad because that's not what you want. Science requires an investment. Science requires a leap of faith, weirdly, and a mutual trust that this is just worth doing because it's worth doing, and that we are philosophically aligned in what we want for the future. And if that's out the window, then these kinds of arrangements are out the window as well. All right, Zapfan just showed up. So why? You must have a better, like my computer should be able to do what yours is doing, Zapfan, but it's not working. I don't know why. Craig H999, when the Earth's magnetic poles flip, is that something catastrophic? Craig H999, when the Earth's magnetic poles flip, is that something catastrophic for the planet, or is it just something that happens and everybody adjusts to it, or is simply unaware of it? We don't know what it's going to feel like for our modern sort of scientific existence when the Earth's poles flip. The last time this happened was about 700,000 years ago. And it's amazing. Like the science that this has been figured out is absolutely incredible. There's this sort of field called paleomagnetism. And what you get is that you have lava flows where lava is coming out of a volcano. And there are these little sort of iron crystals that form inside the lava flow that align with the magnetic field of the Earth at the time. And then if the polarity of the Earth's field flips, then the alignment of these these crystals will flip as well. And so people can go back through ancient lava flows and they can see the directionality of the Earth's magnetic field at different times as they move through the stack and work out on average how long this takes to happen. And what seems to happen is that you sort of go from the Earth polarity being one way. The North magnetic pole is the North Pole of the Earth, and the South magnetic pole is the South Pole of the Earth. And then you enter this kind of jumbled period, and then the flip happens, and now the polarity of the planet is reversed. And it's actually kind of similar to what happens to the polarity flip on the sun, although with the sun one, it is just like clockwork. Every 11 years or so, you get this flip on the sun. And while the Earth's one can vary in length, and we're actually like a little overdue for this polarity flip to happen. And so people see the wandering of the North Pole, and they say, well, maybe this is an indication that the poles are going to flip. If it hasn't happened in hundreds of thousands of years, the chance of it happening in our lifetime is very low. But, on the good news, we don't see any extinction events in the good news is we don't see any extinction events in the fossil record compared to the geomagnetic events. So whatever happens during the polar flip, like there's got to be more radiation that's let into the atmosphere, but maybe the Earth's, maybe the atmosphere can absorb it and protect us down on the surface. We don't see like a die-off every time this happens. So we know that it can't be that catastrophic, but we've never run this against our modern electrical grid. And, the time that I'm recording this, we got a X-class flare off the sun just a couple of days ago. Now there's an aurora alert. I've got clear skies, which is why the telescope is gone. Hopefully we'll be able to, actually the telescopes are gone. The Sea Star and the Dauber are in use. But that means that we'll be able to, hopefully see some auroras. And so when you get these flare activities, and if you don't have that really nice magnetic field around the Earth, more of that radiation makes its way into the Earth and so could cause disruptions to our electrical grid. So the answer is we don't know. And these are the kinds of questions that we need to be able to understand. We have seen in the past the kinds of flares that the sun can throw at us, the Carrington event, and then these events that are even more powerful than Carrington are written into the tree rings back all the way back to about 12,000 years ago, and we just don't know what would happen if the magnetic field was in this jumbled up time, wasn't giving us that nice protection, and we get hit by this really powerful solar flare. We don't know. So the answer is we don't know, but it's the kind of thing that we should be definitely keeping an eye on, be worried about. Subcolons, are there any hypervelocity stars coming from Andromeda? There are almost certainly stars in the Milky Way that originated in Andromeda. We see hypervelocity stars coming out of the Milky Way. Like the escape velocity of the Milky Way is like above 550 kilometers per second. So if a star can go faster than that, either through some kind of recoil event from the supermassive black hole at the heart of the Milky Way, or through being partnered with a supernova, and the supernova goes off and like disappears. Then the star is now, on a slingshot trajectory out of the Milky Way. And so if you do the math, similar events must be happening in Andromeda, and some percentage of stars have been hurled at us from Andromeda. In fact, there's probably clouds of stars that are going past each other between the Milky Way and Andromeda the entire way. So it's amazing, right? There are intergalactic stars, as well as possibly intergalactic objects that have been hurled out of Andromeda in our direction. Same thing with Triangulum. But the question is, like, can we find them? So They're probably out there. I don't know if we'll ever be able to find them. Okay. Joker. Yeah. Joker. How do you feel about the lunar space elevator? Yeah, I've definitely soured on the idea of a space elevator on Earth. I was pretty excited about the idea. It was a fairly science fiction idea for a long time. And when you sort of think back to like when it was originally proposed, I mean, I guess it's been proposed for like 100 years or something, but people got pretty excited about it maybe 25, 30 years ago. It made a ton of sense that right now the whole way that rockets work is that we have to throw them out after every launch. That's ridiculous. What if we could have some system where you don't need to throw out anything, you just use electricity and you climb to the top of this space elevator? And so there's the Space Elevator Foundation, and people would have conferences where they would meet and talk about it. But the problem is that it is just barely within the realm of realism, that the kind of tensile strength required for a space elevator is beyond the strength of any materials that we use today, and is sort of at the theoretical limit of carbon nanotubes that have been woven into these strands. That if you could somehow weave carbon nanotubes longer than a couple of centimeters, which is where we're at right now, then and you could build something that is tens of thousands of kilometers long, and place it, out in space, attach it, bring an asteroid and put it into orbit around the Earth. Like, these are big jobs and require a lot of complexity. And you need to be able to have the power, either electricity or the solar power, to build a climber that can climb up the thing. One thing can only be going on at a time, either up or down, right? Like you can either go all up or all down, but you can't go up and down at the same time. You need to have a second space elevator where things can be going up and things can be going down. So it's a more complicated machine. And the costs were said, well, we could probably get the costs for launching stuff down to, say, $100 per kilogram, which would have been incredible when people look at the launch costs being $5,000 to $10,000 per kilogram. But now SpaceX has delivered partially reusable rockets, and the launch costs are down into the couple of $1,000 range. And theoretically, when Starship finally operates, it should get us into the couple of $100 range. Obviously, Billionaires making estimates of what things are cost. Your mileage may vary, but that's in striking distance. And like, what do? You just build a giant stainless steel tower in the desert, in the Texas desert, and now you're able to get to space at those kinds of costs. So just like the emphasis of a space elevator is starting to make less and less sense. But there's sort of a long way to go to why I'm very excited about it as an idea for the moon. On the moon, we have the materials to be able to build a space elevator. You would go from the surface of the moon to the Earth-Moon L1 Lagrange point. And that you can just use the kinds of fabrics that we have today, like spectra. Like there are these composite fabrics that have been developed. You can buy wire or line made of these composite materials, and they would just work on the moon. The escape velocity of the moon is so low, the gravity that's pulling down is so low, you would be able to pull this off. And then the other place that makes a lot of sense is Mars. That it would be tougher. You would need a stronger material, but still sort of within the realm of realism. And so, say the moon becomes the heart of supplying material to the solar system, for space exploration, where you're carrying ice and volatiles and regolith and refined metals and all that kind of stuff up into space, where you can use it for your O'Neill cylinders and rocket, spaceship construction yards and things like that, a space elevator will probably make a ton of sense. So imagine some future where you've got this space elevator attached to the surface of the moon. The top end is at the L1 Lagrange point. You're carrying payloads up and down from the surface of the moon to a shipyard that is at L1. And the shipyard is building robotic explorers that are then going out across the solar system, and or giant space telescopes that have never needed to be in Earth's gravity. Like, all that's really exciting, and that would be well served by a lunar elevator. So I think we will see a space elevator on the moon long before we see one on the Earth. Paul Wilson, when we are told an object is moving through the solar system at a certain speed, what is that relative to? The Earth? It's usually relative to the sun, because the Earth obviously is in orbit 30 kilometers per second around the sun. And so the velocity of an interstellar object compared to the Earth can change. It could be moving towards us. It could be moving away from us, even though it is moving towards the sun. So yeah, in general, we measure the speed of interstellar objects to the sun. A fish. What would be the unique advantages of a telescope on the moon? Best opportunity for a big interference telescope. So I've actually done a whole interview here on the channel with a researcher who has put together a proposal for the European Space Agency about different kinds of telescopes and stuff that they could do on the moon. And so we kind of cover all our bases on that. The best use of a telescope on the moon is that you put something on the far side of the moon, like a large radio telescope on the far side of the moon. And that lets you observe the signals from the early universe without them being influenced by any radio interference from planet Earth. The problem is that radio signals are everywhere. You are probably wearing at all times several things that are giving off. I carry 3: my watch, my headphones, and my phone at all times. Right. And I am just a source of radio interference, and the whole planet is just terrible. So you go to the far side of the moon, you're now blocking the Earth's radio interference with the mass of the moon, and the moon doesn't have an atmosphere. So even if there are some wavelengths that are fine, even on the surface of the Earth, there are others that you still want to have no atmosphere. So it's always better. So you build a big radio telescope on the far side of the moon, and you observe the earliest times in the universe. You could measure the interaction of a global magnetosphere around an Earth-sized world as flares from the star are hitting it. And then they're giving off these flashes of radio emissions. We would discover habitable exoplanets purely by the radio flashes coming from their magnetospheres. Now that's amazing. So, and there are plans. So there's the ESA and NASA and China are all working on plans to build radio telescopes on the far side of the moon. Now, if you listen to the interview that I did, and we'll put a link in the show notes. There's a bunch of other ideas. A telescope at the South Pole, built into a crater. You could sort of use the shape of the crater as a scaffolding for you to build this giant telescope. So there's a lot of really cool ideas. So check that out. Dougal, what's your confidence level for the Artemis launch in February? Um, so, like it's going to launch, and I'm assuming that everything is just fine for NASA, that they've got, because we've already gone through Artemis 1, they've tested out the Space Launch System, the Orion capsule. There were some issues with the heat shield on the Orion capsule, but apart from that, the mission went exactly as hoped. So this time, of course, you've got precious cargo. You've got people on board. And so everything is going to need to be going without a hitch for them to be willing to let that rocket lift off. And the way things are configured, we get a launch window that opens up in February. And then if they're not able to launch during that window within about a week or so, they then have to wait another 3 weeks for the moon to be back in the same position. And then the launch windows open up again. So we have no idea, right? But I've been through so many of these kinds of things, especially new launches of new vehicles, that they're so careful, so touchy, that they will scrub that launch for any reason whatsoever. They don't like the weather, they scrub that launch. Boats a little too close, they scrub that launch. And if any valve or monitor inside the rocket is causing any kind of concern, then they scrub that launch, and then they wait until they're ready to go again. And then, it's only when it's perfect are they going to be willing to risk the lives of the human beings on that rocket as it goes around the moon. So what is my experience? I think, we'll see a bunch of scrubs, and then we'll see a launch probably within that first window. But your guess is as good as mine. If it turns out that they've been scrubbing launches for 6 months, I wouldn't be surprised either. So this is just how it goes with new hardware. Kissy Kissy, now that NASA has a bigger budget, do you think they'll bring back Starshot? So NASA doesn't have a bigger budget. NASA has a not reduced budget. So the original request from the White House was to cut the budget, to slash the budget, especially the funding for scientific missions. And Congress overturned that decision and pushed for a budget that is very similar to what it was last year. And so a lot of the missions that would have been canceled have been maintained. A lot of the ideas that were going to be done have been maintained, but it's definitely not a increase in budget. It's just like things same as they always were. And so like with the Breakthrough Starshot, keep in mind that was not an investment by NASA. That was a promise from a billionaire that he was going to give $100 million to various people who are going to research the kinds of technology that would go into breakthrough, lasers, light sails, miniaturization of computers, things like that. And so now that none of that's happening, but that doesn't necessarily put it in NASA's wheelhouse or that level of interest. That said, NASA does have NIAC, the Advanced Innovative Concepts Group, and they fund the kinds of projects that are similar to Breakthrough Starshot. They would absolutely fund powerful laser technology, lightweight sails, and have in the past. So I think you might find the researchers who were counting on funding through Breakthrough Starshot to submit their ideas to NASA NIAC and could very well get funding for that. So you would see not millions of dollars, but maybe tens of thousands going to groups that are working on the kinds of technologies that would allow interstellar travel in the far, far future. So, if these ideas are good, someone will eventually fund them. People just have to, I guess, just keep keep working on the project until somebody takes it very seriously. I think like an easy win for an Elon Musk or a Jeff Bezos is to just pick up the torch for Breakthrough Starshot, or some other billionaire who is jealous at Musk and Bezos with their rocket companies and Eric Schmidt. Like someone could just come along and go, sorry, Yuri Milner isn't funding Breakthrough Starshot anymore. I'll do it. Any billionaire, if you want to get into the rocket club, this is your chance. The infrastructure is there. The enthusiasm is there. I get still tons of questions all the time from my audience about what's happening with Breakthrough Starshot. The hunger for humanity to do anything about interstellar travel is off the charts. And anybody who is willing to associate their name with that objective and to actually see through and fund it will have their name written into history. Every time we talk about this project, I will say your name, and so will all of the other space YouTubers, and so will all of the other community discussion forums, and you will be remembered fondly as the individual who helped humanity reach the stars. So, do you want that? Now's your chance. Don't build another wing in a university. Don't fund opera house. Fund interstellar space exploration. Ari Sorlian, can we send a request to Fraser AI Helper for optimization and video compilation? So can you let me know what you want? Like, just put into the chat. So compilations are an idea that I've pitched to Anton. He's a little skeptical that, there are some of the video game streamers that I watch where they do episodic stuff and then they compile it all together into a full version of that. And so, we could do every black hole question answered, or we could do we could do space bites, but we could break up like every Vera Rubin story on Space Bites, and then you could just watch a compilation of all of the Vera Rubin stories. I think that has legs. Anton disagrees. So if you think that's the kind of thing that would be very successful, then you can tell us what you would see. And then you say optimization. What do you mean by optimization? Like, what needs to be optimized? Please let me know. Like calm, sleepy time. It's weird to me that people want to use my voice to go to sleep to, because I see my voice as very sort of frenetic. Pamela, like my co-host on Astronomy Cast, now she is perfect for going to sleep, but I'm always surprised when people are like, oh yeah, I put your videos on and then I go to sleep. I'm like, really? I sometimes I'm shouting, sometimes I'm going really quickly, sometimes I'm going really slowly. Emphasize my words. I'm definitely not using my baritone voice to give you some kind of science explainer that will help you go to sleep. I could, but I don't. Blue Valley, Utah. How do you feel about China wanting to launch 200,000 satellites? I do not like that idea at all. I didn't like Starlink wanting to launch 50,000, and I like even less somebody wanting to launch 200,000 satellites. That's like, yes, high-speed internet would be good, especially for underserved regions of planet Earth, but that's a lot of satellites. Is there no way to get this done without 200,000 satellites? Like, clearly that there needs to be a plan at an international level on what is the right way for us to put together a fleet, a constellation of satellites that makes a ton of sense, because this ad hoc YOLO scenario is going to lead to increased congestion around the Earth. It's going to lead to additional collisions between satellites. and it's going to cause light pollution. Not necessarily light pollution for your eyes, although that many satellites, like there's the direct light pollution, like, oh, I can see a satellite moving across the sky, but there's like an indirect kind of increased sky glow that comes from satellites that is sort of like when the full moon is out and you have a hard time seeing stars out there because there's too much glow in the atmosphere from the moon. You get this sky glow from all of these satellites, and we're already starting to see it with the number of satellites that we have, and we merely have 10,000. Like, imagine when we have 200,000 just from China, which, like, how many is the US going to need? How much will Europe need? How much will Australia want? Everyone's going to roll their own. So no, we need some kind of international agreement about how many satellites and where they should be and what their power is. And like, this is moving to crazy town. It is another commons, and we're about to inflict a tragedy on that commons. Derek Simpson, is it true that we don't know exactly what gravity is? So this is a Sean Carroll question, and in fact, I think Sean answered this exact question recently. So I highly recommend Sean Carroll's Mindscape podcast, and especially his question show that he does every month. They're so good. It's his version of my patrons question show. He takes the questions from the patrons, but he lists the questions, or he lets anyone listen to the output of these. My patrons question show are only for the patrons, so they ask the questions and then they listen to the episodes. But he got this question. And, you know, if I sort of remember Sean Carroll's answer to this question, you sort of break it into two things. So on the one hand, look, what is gravity? Gravity is the distortion of space-time by mass. It's not things pulling other things. It really seems that, you know, whenever you have mass, then the mass distorts the space-time, and things are following what they think is a straight line, but it's actually a curved line through space-time, and it has implications for time and all this kind of stuff, right? It's a very complicated thing that Einstein was able to uncover, the truth. And before that, Newton had his ideas about how gravity worked, but he didn't really understand what the cause was. But even with Einstein, why does mass cause space-time to distort? We don't know. We don't understand. We know how to make predictions that use it. We can calculate the precise position of Mercury thousands of years into the future because we understand frame dragging and what's happening with the sun's distortion of space-time. But we don't know why at the deepest level. And even if we did discover, oh, I see, there's like little particles that are bouncing back and forth that are reaching every part of space-time, and they are distorting the space-time in this very specific way, you'd be like, why? And then you're like, well, we don't really know. And then you figure that out and you're like, yeah, but why? And we don't really know. That we understand, and this is kind of the amazing thing about science, is that we understand the behavior of the universe to a level that we can predict the future of events. That's sort of one of the great things, one of the reasons why science is so useful. But you may never reach the end of your journey to understand the underlying root cause for why things happen. And that may just be a thing that you have to be okay with, right? The example that I always get is people ask me, where did the universe come from? And my answer is, we don't know. We don't know, right? Let's find out. Let's try our best to investigate every line of evidence that seems interesting. Let's build telescopes to understand the history of the universe's evolution, and hope that we see some glimmer, some echo of the universe that came from the universe that was here before us. But we don't know that if that evidence will ever be turned up. And for a lot of our lives, for a lot of this, we know enough about these things so that we can use them to live our lives. Run our computers, fly in an airplane, play a basketball game. Our understanding of gravity is good enough. But, and this is where I think you get this real disconnection between, say, science, which lives in uncertainty, and religion, which offers certainty. Right? Where did the universe come from? God made it. Okay, thanks. Got it. Right? And question answered. I no longer need to investigate because someone gave me the answer. And science doesn't work that way. Science says we don't know. Science is very upfront about the things that they don't know the answer to. And they declare it without any anxiousness or awkwardness. Where did the universe come from? We don't know. Where did life first form on the earth? We don't know. What is dark matter? We don't know. What is dark energy? We don't know. Right? We don't know. We don't know. We don't know. What will happen to the future of the universe? We don't know. Is there a reason to be here? We don't know. Why is there something in nothing? We don't know. So when you get to this place where you're comfortable and even excited that there are things you don't know, then you no longer seek certainty in your life in that same way, right? Those things you have the certainty of the uncertainty, which has a charm all its own. Paige Potter, what is your space Roman Empire thought that you keep returning to lately? Yeah, this is funny. There's like that meme on TikTok or something where people are asking their spouses how often they think about the Roman Empire, and it turns out people think about it every day, or people think about it every week. And obviously people are cherry picking. I'm sure there's a lot of us out there that don't think about the Roman Empire very often, unless we're listening to a new episode of Hardcore History, or we're watching the TV show Rome for the third time. I don't think about Rome very often. I think about historical civilizations on a regular basis, but I love that whole meme. There's something very funny about that. So what is the thing? So for me right now, and I think I kind of covered this in a recent interview that I did, which is that I am haunted by people's distrust in science and expertise. And when you look at the comments by people on the interview that I did, there's a lot of, well, I would trust science, but they blew it so badly on this. They turned this thing that should be science into politics. They're telling me how to, they've turned the virus into a political conversation. They've turned climate change into a political conversation. They've turned the definition of gender into a political conversation. And to that I respond, no, they have not. They have not turned those things into political conversations. People who have a political axe to grind have convinced people that the scientists have turned those into a political conversation, but they have not. And so you get a real sense of like just a baffled, for me, I am just baffled by watching people have this response and essentially gulp down the talking points of political or disinformation campaigns, essentially, right? That climate change is the greatest example of this. That you can learn, we knew 100 years ago what putting carbon dioxide into the atmosphere would do to the temperatures on planet Earth. You can take a chemistry course. You can calculate the volume of the atmosphere on Earth. You can calculate the solar irradiance that's coming into the planet. You can calculate the amount of carbon dioxide that's present in the atmosphere. And you can calculate the average temperature of planet Earth. And you will get it, you will nail it to within some tiny fraction of a degree, right? You will get exactly. And then you go, well, what will the average temperature on Earth be if the amount of carbon dioxide in the atmosphere rises to this level? You make this calculation and you will nail it. And this is like, literally, this is all that scientists are saying is, we did this very simple mathematical equation and this was the result. And then you have to then add on the complexities of land masses and ocean and the salinity of the ocean and the Arctic currents, and like there's a lot of things that make it more complicated. And then you could say, well, what is the consequence? What's the consequences of the temperature rising? Well, you can tell the amount of sea level rise. You can tell the amount of strength of hurricanes. Like all of these things fall as outcomes of this scientific question. And then the scientists have just presented this. But this is an unacceptable answer for various entrenched interests. And so they have muddied the waters. They have paid giant farms of people to get out there and do hand-to-hand combat with people's beliefs in a way that is stuck beautifully. Chef's kiss, congratulations. You completely undermined the public's trust and belief in what should be a very non-political place. And I think that science, obviously people make mistakes, but then there is this system designed to jump on every possible mistake, right? And use that as an example for all scientists are bad. There are YouTubers that are using individual examples to then cast a negative light across all science, and that is bananas to me. So that totally haunts me, because I can't for the life of me think about how we negotiate or how we navigate back to a place where this is no longer the case. I have a friend who is conspiratorial leaning, and, we sit and we hang out and we discuss the things that he's running up against, and we go through this process of fact checking and looking for sources, and I sort of bring him around at the end of the conversation, while having what I think is a very fun, engaging, well-meaning conversation with him. And I really enjoy that process because I know that he is coming at this in good faith. But I also watch people having very cynical conversations on the internet and so on, and it's not in good faith. And that is a disconnect for me that is really hard to square, that people are having arguments in bad faith, right? That's tough. They're just looking to score political points for their side. And it happens on both sides, right? And so I think a lot about that. And I think a lot about it because I think it is a problem that must be solved. That if we don't solve this problem, then all we get is more division. And yet I can't for the life of me think about how to solve it. If I can't solve this problem with a person who I interact with directly and just sort of like have these conversations and slowly try to provide a more balanced scientific perspective of facts-based perspective of the world, how can we do this at scale when we have built tools like AI that automate and accelerate our ability to mislead one another, to deepen our divisions? This is tough for me. And I'm generally a very optimistic person, and it's funny because I ranted about this in the recent Patrons podcast, and Anton, who's normally, right, Ukrainian, he's not living in his country anymore, because he has a generally more negative perspective on world affairs than I do, and he like tried to buck me up. He's like, come on, like, gave me reasons why these things go back and forth and so on. So anyway, that is my Roman Empire. And that if you know me in real life and you see me with a 1,000-yard stare and I'm thinking about something, you could say, you're thinking about the distrust in science and how to fix it, aren't you? I'm like, yeah, I am. So that is my space Roman Empire right now is how do we fix distrust and a lack of respect for expertise. What does it mean when there's no reason to get good at something, when things require us being good at them? I don't know. Dude, would you get any closer to speaking with the Canadian government about their space policy? No. It's funny. Oh, God, Canada. I'm trying to help you here. I send emails. It's funny. Like, I sent an email to the Canadian Space Agency. I'm like, hey, can I talk to literally anybody about Canadian space exploration? And they're like, nah, we're a little busy right now. They're not. Anyway, I'll try again. New country, new leadership. We'll see what happens. Where are we at? Okay. Paige Potter, do scientists get steps in space, or is that a metric meaningless in microgravity? How many steps would you recommend we average folks get here on Earth per day? So it's funny. I mean, like, astronauts have to exercise all the time to counteract the being in microgravity. So we know that it weakens your bones, it causes loss of muscle. So you need to exercise, and they exercise hours and hours every day. They have a treadmill, the Colbert treadmill that they're on, that allows them to build up their cardiovascular fitness. And then they also have a weight machine that allows them to do squats and deadlifts and leg, I'm trying to think, like various leg exercises. And it's brutal. Like, can you imagine that you're going to go on some adventure? Like, I don't know, you're going to go on an adventure to Antarctica, or you're going to go on an adventure, a balloon trip or something like that. I don't know, something weird and extreme. You're going to go on an icebreaker to the Arctic. But then you also have to spend 3 hours a day working out just to prevent the downside of being in those kinds of conditions. I mean, you think about like what, say, the people who are climbing Mount Everest have to do. If you aren't acclimatized to the area, you have to climb up a chunk of Mount Everest and then come back down, and then climb up a little bit higher and then come back down, climb up a little bit higher and come back down. Like, you don't just get to climb that mountain. You have to climb that mountain every day for weeks before you have conditioned your body so that you can actually climb that mountain. And so that's the level of maintenance. And so, like, the steps, I'm sure they can measure their steps on the treadmill, and the rest of the time you're like floating around in this really unhelpful state to your body, that you're awake all day doing work on the station, and is equivalent to you spending your day in bed. And that's why researchers use bed rest as an analogy for space exploration, that they want to know what's going to happen to a person's body. They put them in bed for a month, and that gives them a glimpse of what's going to happen to the human body when it's in space. How many steps do you recommend? Man, walking is so great. I love to walk. I walk a ton. And a lot of people do a lot of cardio, but the recommendation from the fitness influencers is focus on walking instead. Like, get above 10,000 steps 12,000 steps in a day as just like a baseline for what you do. And don't try to go too high, because if you go too high, then it kind of kicks in your hunger and you just want to eat and eat and eat. And that counteracts if you're trying to do any weight loss. But yeah, 10, 12,000 steps is a good number to go to just keep moving. It's really hard for me because I sit in front of my computer all day working. So I have to come up with artificial ways to remind myself to go out and work. Get out and do something, use your body, then come back, stretch it over the course of the day, so you build up those steps. My current thing is I've got my treadmill and I've got a TV hooked up to it and my an older computer that plays video games, and then I can walk on the treadmill with my controller and play video games, and the time just vaporizes. Like I don't even experience it. Like, whoa, it's been an hour and a half I've been on the treadmill. That's amazing. So yeah, that's my recommendation. Treadmills, video games. Not television. Even television is like too boring. So we're good. Okay. Thomas Starkey, would you consider doing a long-form interview on the Earth 2.0 Hunter satellite from the Chinese Space Agency? I really enjoyed your interview regarding ESA's Plato mission. Absolutely. I've sent probably 10 emails to people in the Chinese Space Agency to conduct interviews with people associated with the telescopes. I wanted to find somebody just with the Chinese space telescope, but as you said, the Earth 2.0 Hunter. That would be amazing. They are, so, part of it is that I think I'm sending messages from a web server or an email server that is run by Google. Like I use Google's email server for Universe Today. So I probably need to get off of Google's email server, which is like a de-Googlification that I should be doing anyway. Or if I send it from my personal, my Gmail account, again, so that's probably getting blocked by the Great Firewall. I know that people in China are looking at Universe Today. I can see traffic from there. So that's challenge number one, is just like even anybody inside China taking my request seriously. Challenge number two is finding somebody who has a good accent, unfortunately, a good fluent use of the language. We do a lot of interviews with people where English is their second language, and we see a drop off for sure that people are like, well, they might be saying something that's really interesting, but their accent is so heavy that I don't want to listen to this anymore. And that's unfortunate, but I get it. Like, I'm listening to the interview and I'm focusing really carefully and really trying to pick up the value of the things that they're saying. But I totally get that if a person has a very thick accent, it's too difficult to listen to them. So you need to find the people who have really fluent English accents. And they're there, right? When you think about the kinds of people that are throughout the organization, you've got people that maybe were born in Canada or born in the US and are working in the Chinese Space Agency. Or they grew up in China, but they went to a school where they were learning, the English, a lot of English in it. Or they went at a young age and they went to the US and learned English and they have a fluent accent and they go back to China. Like, those people are all throughout the organization. And so those would be the ideal, is a person who's working on a project like that that's really interesting and also is very fluent and can communicate that. And I have a really hard time finding the kinds of people who can connect me with that kind of audience. The other idea, which is, we're kind of not ready for that yet, both sort of philosophically and technologically, is that you could help, like, have a person speak in their native language. And if you want to listen to the native language, then by all means, but you could also hear an AI version where it's translating them into English, but it's still using their voice. It sounds like their voice. That would be really cool. That feels to me like it would be a responsible use of artificial intelligence. And then you could just listen. Do I want the dubbed version, or do I want in their native language version? Either way would be cool. And I would love, really the goal for me is, like, I would love to be able to conduct that interview in Chinese. Like, that would be amazing. And then we could dub, I can re-record my side of the conversation, and then we can provide either like a voice actor to do the English side of their conversation, or we can just, use an AI to dub it in English. That would be really cool. So I would love to be able to interview people. And I'm sure 5 years from now, this problem will just go away. I'll be like, I'll reach out to somebody in China. They'll respond. They'll come on the interview. They'll speak whatever language they want. I'll speak whatever language I want. It'll all be automatically translated. You'll be able to watch it. It'll be very cool. But we're not quite there yet. And so we're having to focus more on reporting in text. So we do a lot of reporting on that kind of stuff on Universe today. But I think a lot, maybe that is my Roman Empire. I think a lot about how to showcase the work of people who are working on space exploration that aren't speaking English. Because all the amazing people in Japan, people in China, there's a lot of really great work that is going on. So, and we see this very English-centric, very US-centric perspective, which, obviously under the current political climate, it'd be great to showcase this great world that we live in. India is great because everybody in India speaks English. And so I find Indian researchers are very, easy to interview, and that's sort of like a very ready group. And there's a lot of really interesting work coming out of India. So I tend to I don't really have any hesitation when I see, somewhere India. I know they're going to have a certain level of English proficiency. Okay. But I would love, cracking into understanding the Chinese. I need to spend more time on it because I'm always just highballing and just trying to get through stuff as quickly as I can. But I really should just spend a chunk of time on Weibo, which is the Chinese Twitter. And I've followed a bunch of Chinese related space channels on Weibo, but it's written in Chinese, very complex Chinese. So it's very hard for me to get the gist of what's going on to see the news. But there is this, I think we in the West, we don't appreciate that there is this parallel universe of all of the kinds of things that we do on YouTube, on the web, on Twitter, etc. There is a version of that over on China where people are talking about new missions from the Chinese Space Agency and the kinds of rocket launches and the moon missions, and people are explaining science fiction concepts. There's a person out there on Weibo or on Bilibili or something like that is like me, but is doing this kind of stuff in Chinese. And I want to be that guy. So learn Chinese, baby. I am. What's actually she doing? In Kalen videos, what games you play? Have you tried Space Engine? I've tried Space Engine. It's, we use it as a tool for showing the cosmos. I know Anton Petrov uses it quite a bit. It's cool. It's very cool. And then I've recently, I literally just in a recent question show sort of went through all the video games that I play, but mainly right now, Path of Exile, Path of Exile 2, Project Zomboid, Stellaris, RimWorld, Slay the Spire. That's what I'm playing right now-ish. George Gernescu. Are there any current proposals for AI software in rovers or space probes to increase their capabilities? There's a lot of machine learning that goes into spacecraft already. There's a lot of tasks that spacecraft need to be able to handle autonomously. And I think the example that I give most often is the Mars Perseverance rover, which landed on the surface of Mars back man, several years ago. And so when it was coming in, it was taking images of the surface of Mars. It had a landing ellipse where it was expected to actually land on the surface of Mars, but it was trying to pick its own landing spot with maximum safety. And so and the controllers back on Earth, because there's a multi-minute delay, you can't, the entire landing system all comes together within whatever 5-8 minutes. You don't have a lot of time to pick a landing spot, and so Perseverance had to choose its own landing spot. And so it was able to scan the terrain of the surface underneath it, find places that were largely rock free, and then direct its final descent so that it could land at that place, and did that all autonomously. It had a machine learning algorithm that had been trained to both identify the terrain, figure out what is a good landing spot, what is a bad landing spot, and then direct its thrusters so that it could land safely like that. And there's been a bunch of other examples like that. And being able to explore the solar system beyond just instantaneous back and forth time is going to be critical. That you need to be able to say, and even on Perseverance, like you can now say, go over there, and Perseverance will handle the avoidance as it's driving over there. That it will drive around rocks. It will sort of consider the slipperiness of the steepness of the slope of the sand and all that kind of stuff, and make a lot of these decisions. And so we see Perseverance putting many more kilometers under wheel than what we saw with any previous rover. And that's going to be the key, even on the moon. I mean, the moon still has a half-second time, but can you imagine playing a video game with a 500 millisecond, or I guess 1,000 millisecond response time? That would be brutal. So you're going to want this increasing levels of autonomy. There's a lot of stuff that happens in space. Think about space telescopes, where there could be some bright flash that happens because a gamma ray burst is happening. You need the telescope to quickly turn and observe that object in under a second. Begin the process of making its observations. This all needs to be autonomous. So there's a ton of machine learning. And now, because so much work is going into AI, this technology is getting better and better and better. I don't think generative AI has any real value in space exploration. You're not going to need a rover to be able to generate examples of astronauts riding horses or write text that's of any value. But machine learning, absolutely. And this is my hope with just AI, the rush into AI in general, is that all of this hardware is being built, all this infrastructure is being created, and most of it is just ridiculously used, like Sora, right? Like making videos of your friends getting stopped by traffic cops is dumb. But all that hardware, all that iron can be used, the big iron can be used for us to do science, for us to fold genomes, for us to search for signals from extraterrestrials, for us to learn how to identify craters on the surface of the moon. And I would love, if there is an AI crash, then I would love that compute to be cheap so that we can do science on it. In the same way, when you think about the internet, right, there was all that dark fiber. People thought that they would need all of this fiber, and so they installed all this fiber capacity, and then it all crashed. It's all picked up for a fraction of the price, and the modern internet runs on that infrastructure that was laid down 30 years ago. Fritzelli, do you think we'll see a permanent human presence on Mars in our lifetime? Lifetime being wide-ranging. Yes. Yeah. I mean, it depends on your life. I'm 54. Let's imagine I'm going to live to my mid-80s. I got another 30 years left. Will there be a permanent base on Mars by 2055? I think so. I think it'll be like this tiny little station with a couple of people. They're rotating. Yes. Definitely on the moon. Christian Asalier, does the cosmic microwave background have a redshift value? It does. I think it's 1,000. Let me just confirm. Oh, so 1,100. Okay. Yes, the cosmic microwave background radiation has a redshift of up to 1,100. So Z equals 1,100. And it's funny, and that is seen at a time when the universe was 380,000 years old. I wonder what the redshift of the Big Bang itself would be. That's an interesting question. I'll need to dig that one out. But, and when you think about the most distant galaxies, often astronomers, when they're thinking about really far distances, they're thinking about redshift 0. But the most distant galaxies that have ever been seen are in the redshift 13 range. And that is just a couple of 100 million years after the Big Bang. So the redshift numbers go up precipitously beyond, into the first few 100,000 years after the Big Bang. Infinite Z. Big Bang is infinite. Yeah, the very beginning of the Big Bang is probably infinite. Let's see if anyone's written about this. Big Bang redshift value. No. That'd be cool. That'd be an interesting question. I'll throw that at one of the astrophysicists on Universe Today. I love the question. Roger Luther, anyone looking forward to the new Stargate continuation series? Of course. Stargate is the best, right? Stargate, Star Trek, Star Wars way below, except for Andor. Andor is the best, but yet Stargate is the best. Anyway, I like Stargate the best. My wife and I are going through a rewatching of the Stargate series, and they're so good. They still hold up. I really enjoy them. So I would love for there to be I know it's been announced, but a lot of things have been announced. But on that note, we watched the new Starfleet Academy show, and it was fine. The first episode I would call the first episode good. The second episode was bad, boring, but they average out to fine. So I think the first episode was like, okay, no, this is really good. It's kind of funny. The characters are good. Parts of it feel really cringy. Everything's a little too bright and shiny, and the second episode really took on the CW feel that I was really hoping it wasn't going to have, and that was unfortunate. So if they can make it better, we'll see how it happens with episode 3. But so far, the first one was good. I liked it a lot. Second one was mediocre. Dragged it down. So now they've got to sort of right the ship from this point forward. But a thing that I find really funny is that, I know this has nothing to do with your Stargate, but we're talking about Star Trek now, is that people really whined about Discovery. And when you think about Star Trek Discovery, there wasn't a cis-het character in the main cast and crew, except for the actor underneath the alien, Suresh. Anyway, and like a lot of people were like, oh, it's so woke, and but like that was the point. And when you think about Star Trek, the original old show, where you had Uhuru, black woman, right? First interracial kiss on television. You had Sulu, right? Japanese. This is like people are still sort of concerned about what happened with the Korean War, with World War II. And then you had Chekhov, a Russian, as an officer on board. They were pushing boundaries that Gene Roddenberry was saying, like, what could the future look like? Could you have this kind of inclusion in ways that are deeply uncomfortable? And you would imagine that if there was an internet back then, people would be screaming how woke Star Trek, just the original show, was. And I'm sure people were whining about what happened in the Next Generation. And so I kind of liked the idea of like, well, what if we make a cast that is diverse, that is purposefully more diverse than we see in our modern society? What happens, right? Well, they're competent. They get the job done. The show itself wasn't great. There was a bunch of stuff that I thought was really great, other stuff that I didn't like. But the thing that I really respected them for was doing the thing that I'm sure a lot of people wrote the show off for. And yet I feel like if you like Star Trek, you want the show to challenge your perspective on what the future might look like. To take these things that you have an instinctual response, a negative response against, and go, thank you, Star Trek, for pushing me in and potentially expanding my mind. That's Star Trek's job. And that, when we think about, there was always this natural response to media in the past, comic books, right? Run Dungeons and Dragons. It's going to turn us all into demon cultists. So anyway, I thought that was my when I was watching that show, I was deeply appreciative of how much it was pushing that woke narrative. I enjoyed it for that reason, because it was kind of like going, hey, what if future looks like this, right? Future could look, these are the things we're facing right now. Let's integrate that into a future. So I thought it was awesome. Okay. Yeah, people saying I didn't notice anything woke on Discovery. It was just a horrid storyline. Yeah, so my downside was that the stories weren't great, right? The stories weren't great. A lot of it I found very boring. I wasn't really pushed in that direction. While I find, say, Strange New Worlds was much better, right? The stories there felt much more like kind of classic Star Trek, like telling interesting little science fiction nuggets, and I found that really entertaining. So that's what I want. I want the two to come together. I want my science fiction to give me uncomfortable look at the problems of today's society with super fun ideas. Pluribus really kind of nails it. And I would say Alien Earth really nailed it too. Like if there was two shows which jumped onto my list of favorite science fiction ever, Pluribus and Alien Earth both did that in that same way, right? Like Pluribus is a clearly there's something else going on here. Are we talking about artificial intelligence in the sort of the way they interact with each other? Well, the show was designed before we had the modern AI, so like they were so prescient. Are we just talking about like what does it mean to be individual versus, where you have sort of some societies are more individualistic and other societies are more collectivist, and that you have these downsides of both, that if you come from a place like Japan, you're expected to be in this sort of community and respect your elders and serve your parents. Well, if you come from this, like my culture, Canada, but or the US, you're kind of on your own, right? You're designed to make your own way through life. You don't have that built-in community of friends and family and so on. So maybe that's what it's about. And also really cool ideas about the hive mind and the way people behave and all that. I really enjoyed that. And then Alien Earth was about like, what if we just let the corporations have everything, right? Like what if they can do whatever they want? They run the country, they run the world. What then? Interesting question. And also crazy new versions of like not just the xenomorphs, which I am frankly bored of, right? If you show me a xenomorph, yawn. But you show me a crazy eyeball monster, now I'm interested. So I really enjoyed them injecting a bunch of new life forms into the aliens mix. Yeah, both of those shows. If you want like a third one, Scavenger's Reign will also sort of blow your mind in terms of this bizarre world where life does really unusual things and people are trying to survive on this. I don't know if it has any kind of allegory to our modern life, but boy, is it a good show. Really makes you think about how weird life can be. So I highly recommend that as well. Farscape. We're just literally as soon as we finish. Someone's mentioning Farscape, Raj Luthra. So as soon as we finish, Stargate SG1, we're gonna hit Farscape. Which Stargate is my favorite. Farscape is my wife's favorite. It's her comfort food, and she watched Farscape a bunch of times. I only watched a couple of episodes. I never really got into it. So I'm actually really looking forward to watching Farscape with her and seeing it kind of through her eyes. So yeah. And Roger was mentioning Dark Matter, Expanse, and Orville. Obviously The Expanse is probably the greatest science fiction television show ever made. The Orville is good, and apparently it's got picked up for a 4th season. The first couple of seasons really captured the magic of Star Trek: The Next Generation. I really enjoyed it. The 3rd season started to go downhill, and I was a little less enthusiastic about it. I've sent emails to Seth MacFarlane saying hey, let me pitch just general concepts in space and astronomy that you could incorporate into the show, because there's some really interesting stuff that you would have a lot of fun with. He hasn't got back to me. So if you're watching right now, Seth, the offer still stands. Okay. Man, I love television too much. Or not enough. All right. Fraser, tell us your 2026 thoughts on AI slop. I feel like I've covered my thoughts on this whole thing. This point. See, Luigi Daisy, Fraser, do you like hockey? I actually answered this in a recent question show. No, I do not like hockey, which obviously makes me a pariah from my fellow citizens. That every party, every social event I will go to, people will talk about hockey, and I just look dumbfounded. Melantorja will ants ever evolve to develop space travel? Ants right now, probably not. But if we mess this up and we drive ourselves to extinction, we're probably not going to kill the ants. The ants are tough and can handle really dry, really hot, really cold. They can handle all kinds of terrain, and the ants are well positioned to take over the planet. The problem is that insects have a body plan that doesn't scale up very big. So you really can't make a large insect in the way that you can make a large mammal, like a blue whale, right? Or even just like a person. You can't get an ant the size of a person. So you need a completely different body plan and a lot of evolutionary changes for them to be able to do it. So I can imagine the ants maybe evolving some kind of collective intelligence to the point where they can develop various technologies and use that as a way to bootstrap themselves up. Maybe they'll be the ones who will develop some kind of robotic suit. You can imagine there's some little ant inside this giant robot walking around. That'd be cool. There's an idea that I really like, that you get this collective intelligence through the emergence of simpler activities, that you consider the kind of cognitive power of an ant hill, that any one individual ant is very much like a tiny little robot. It has a lack of freedom, and you kind of wonder if there's anything, is there anything, what would it feel like to be an ant? What would go through your mind? Probably not very much. and that they have various, but yet they can follow a path, or they can lay down a path, or they can find food, and they can carry the food back, and so on. And yet at a higher level, when you look at the emergent behavior of all of the ants, there is this, that it can solve problems. It can handle resource constraints. It can move itself if problems get too big. It can cross, you look at the army ants where they can cross rivers and things like that, that there is these larger behaviors, this larger cognition that is going on, even though the individual ants themselves. And like, what are we, right? We are just a meat bag filled with cells, and that our emergent behavior of being a person, about thinking about things, about going to the moon, comes from the emergent behavior of all of the individual cells that make up our body. And so could that be, instead of it glued together in the way that we are, could you have some kind of intelligence that comes from a, separated group of individuals that are working together for some purpose? Is that a computer, where when you think about a computer, like a computer is really just all of the different electronics that come together to make the capabilities of the computer, transistors, right? So I think, it's probably, possibly, perfectly reasonable that you could have some kind of higher cognitive intelligence arise through the sum of some smaller component. Ants making an intelligent ant hive. And maybe given long enough, and maybe if there's some kind of evolutionary advantage to getting smarter, that you would have some kind of hive entity gaining intelligence in some kind of way. And not like a telepathic hive mind in the way it's done in Pluribus, but just that you have enough parts working together, it can start to accomplish interesting problems. And then you wonder, like, what is consciousness, right? Is this thing that is making technology, if an ant nest could make technology, could build a bridge across a river and make something permanent, right? Is it thinking? How is it having a thought? Is it aware of its own existence? That's super weird. So, could the ants evolve to develop space travel? Maybe. We'll have to make ourselves extinct first to find out. But my money's on the octopuses. I think they're well positioned to pick up the mantle after we fumble it. All right, we've reached the end of our episode. Thank you, everyone who hung out today. Thanks to the mods. Thanks to Roger Luther and Zapvan. Clearly, I need to talk with Chad about making the robot be able to read the comments better. So what do we got? We got a long old interview that I did that we never got around to releasing, and hopefully we'll have that released this week. And then I've got a bunch of just zinger interviews that I did that I think you're really going to enjoy. So we're probably going to start doubling up on interviews for the next couple of weeks, probably 2 interviews a week. So stay tuned for all that. No astronomy cast later today. Pamela is traveling, so you don't have to worry about that happening at 11 o'clock. And then next week, we'll be back to our normal bat time, normal bat channel. All right. Well, thanks, everyone. That was super fun. And we will see you all next time. Maybe telescope live stream tonight. Maybe. I think I've sorted a bunch of problems, and so maybe. All right. We'll talk to you later. Press the button. Where's the button?